Have you ever used an app that just works? It's smooth, it's reliable, it never seems to crash on you. Well, guess what? That isn't magic. It's something called good architecture. So today, we're going to pull back the curtain and look at the blueprint that powers all the best apps out there so you can start using it too. Let's dive in. So, let's kick things off with a problem that I think we've all felt. You're working on your app, right? You make one tiny little change over here, and suddenly, three completely unrelated things over there just break. If that sounds familiar, you are definitely not alone. This kind of super fragile code almost always happens for one reason. Everything's tangled together with no real structure. And this slide right here, it just says it all. On the left, you've got the all-in-one mess. This is the trap we all fall into at first, where all the code for the screen, the code for the data, the code for the logic, it all just gets dumped into one giant file. It's a total mess. But the solution, over on the right, is so simple and so powerful. Give each part of the app its own distinct job. That, right there, is the heart of good architecture. Now, this beautiful idea has a name. It's called separation of concerns. And honestly, you can just think of it like a professional kitchen. You've got a chef who cooks, a server who takes orders, and a dishwasher who cleans. Nobody tries to do everyone else's job, right? It'd be chaos. It's the same with your app. Your UI code should only worry about what the user sees, and your data code should only worry about the information. Getting this separation right is the #1 key to building apps that don't just randomly break. So how do we actually do this? Well, we use a layered architecture. As you can see, there are typically 3 layers we talk about. The UI layer is what the user sees and touches. The data layer, that handles all the app's info and its rules, what we call business logic. And then for really complicated apps, sometimes there's an optional domain layer sandwiched in the middle. But for today, we're going to focus on the 2 essential layers that pretty much every single app needs, the UI and the data layers.
All right, first up, the UI layer. Let's give it a nickname, the storefront. It's everything your user actually sees and touches. All the buttons, the images, the text on the screen. It is literally the beautiful face of your entire operation.
And the UI layer's job is wonderfully, beautifully simple. It really only has 2 main responsibilities. First, it displays data on the screen, and second, it captures what the user does, like a button tap. That's it. That is its entire job. And here is the absolutely crucial part. The UI layer is wonderfully dumb. It doesn't know how to get the data or what a button press actually means. It just displays what it's given and tells the rest of the app when the user does something.
Okay, so let's move on to the other critical piece, the data layer. If the UI is the storefront, then the data layer is the vault and the back office all rolled into one. This is the real brain of your app. It holds all the important rules, the business logic, and it's in charge of managing all of the app's valuable information.
Now, the data layer itself is usually made of 2 key parts. First, you've got the repository. Think of this as the general manager of your data. It oversees everything. Then you have data sources. These are your specialists. Each one is an expert in getting data from exactly one place, like from the internet or from a database on the phone. And this setup creates a really important rule. The rest of your app is only allowed to talk to the general manager, the repository. It never gets to bother the specialist directly. This keeps all the communication neat and tidy, and it prevents total chaos. And this whole structure, it allows us to build another critical concept, the single source of truth. All this means is that for any piece of data in your app, there is one and only one place that is the final authority on what that data is. This is how you prevent those bizarre bugs where, one part of your app thinks your name is Alex, but another part thinks it's Alexander. When you have one source of truth, every single part of your app sees the same consistent information, always. Okay, so we've got our separate layers. The UI is the storefront, the data layer is the vault. Awesome. But how do they talk to each other without just creating another one of those tangled messes we started with? Well, they do it in a very clean, very predictable way. And this predictable communication pattern is called unidirectional data flow, or UDF for short. Now, it sounds kind of fancy, but the idea is incredibly simple and powerful. Data, or what we call state, only ever flows in one direction, down, from the brains of the app to the screen. And user actions, or events, only ever flow in the opposite direction, up, from the screen to the brains. It's like a one-way street system for your app's information. Let me show you how it works. So it all starts with the user. They tap a button to, let's say, add an item to their shopping cart. The UI layer sees this tap and it creates something called an event. And that event immediately starts flowing up, away from the screen.
Now remember how we said the UI layer is dumb? It has no idea what add to cart even means. Its only job is to pass that event up to the data layer, and it's basically just saying, hey, the user did this thing.
Now, the data layer, our single source of truth, receives that event, and it knows exactly what to do. It runs its logic, it updates the shopping carts data inside itself, and it creates a new updated version of the app's state. And this is what completes the loop. That new state, the one with the updated cart, now flows back down to the UI layer. And what's the UI's simple job? It sees the new data, and it just redraws the screen to show the item is now in the cart. It's clean, it's predictable, and it's so much easier to debug.
So why on earth do we go through all this trouble? What's the payoff? Well, the benefits are absolutely massive. Following these principles makes your app way easier to maintain and just improves its overall quality. It lets your app scale from a tiny little project to a huge one with a big team. Each piece is testable, all by itself. New developers can jump in and get started faster because the structure is so clear, and maybe best of all, it leads to way fewer bugs.
And hey, this isn't just some trendy idea I'm talking about. It's a foundational best practice. The official Android Developers Guide itself puts it perfectly. A good architecture improves the maintainability, quality, and robustness of the overall app. Can't say it better than that. So the next time you start a new project, or maybe even when you look at an old one, just ask yourself, is this a tangled mess or is it built on a solid foundation? Is my app actually built to last? Thanks for digging into all this architecture stuff with me today.